Okay, so this is joint work with myself and Joe Gersch, who's in the back here as well. So we're both here to take questions, tomatoes, whatever you have to send our way. Okay, so what we're going to, oops, okay, it's got to be a better way to do this. Sorry, I'm not a Microsoft guy. Okay, so what we want to talk about here today is associating data with CIDR prefixes, right? So, there's been some active work on doing this for storing routing information in the DNS. This is not a routing information in the DNS talk specifically. There's a lot of reasons that you might want to put data about a prefix somewhere. Right? We want to know things about prefix ownership. This was some of the work that originally led to this. How do you know who owns a prefix? Can you identify a responsible party for a prefix? There's a lot of interesting services in prefix management. Who are the authorized mail servers, the NTP servers? How do you manage your Reverse-DNS for V6? So V6, if you haven't already seen, there's a great draft by Howard, and a lot of people have been looking at IPv6, and simply encoding V6 data in V6 pointer records into Reverse-DNS can take you, trillions of years at a reasonable pace. Right? It's a big space. So there's an issue there. There's an issue with, could we do it to store some kind of routing operational data? And we'll point you to a test bed later if you want to try down that direction. But potentially I want to come across this. There's a vast number of applications that could be enabled if we could store data with a prefix. But this data is only going to be useful if we can authenticate it. Kind of wrapping back toward the Dane talk that Matt was giving earlier is, okay, how could we do this? Right, so, okay. All right, so what we claim we ought to do, and why we're here, right, is we ought to store this data in the Reverse-DNS. The Reverse-DNS is the right home for this. Okay, so first, the Reverse-DNS is already there. This is a DNS crowd. We know Reverse-DNS, right? We all know that we can put pointer records in there. We can pick an IP address, and we can map a host name back. We can make an IP address back to a host name. There's an existing delegation structure. This is not something we have to create new. We don't have to come out and define a new hierarchy, solve new hierarchy issues. We have it there. We have existing operational practices for running the thing. So there's a lot of momentum here where you could actually use this. You throw it in DNSSEC, which we're all interested in being here at this meeting. We don't have to invent a whole new system for how are we going to roll the keys, right? Earlier today we saw this whole paper on how do you roll the keys. You're going to build an entirely new infrastructure. You're going to build an entirely new way to manage keys. We have that with DNSSEC. I can authenticate a given record. I have a large base of existing clients, from libraries to tool sets to even dig, that if I could put this data into the Reverse-DNS, I could do it now. So our argument here is we ought to have a way to put prefixes in the Reverse-DNS, not just addresses. Reverse-DNS should be more than addresses. It should be prefixes. And that's the main message we want to try to drive home. So then you might say, okay, well, doesn't that already work? I mean, I already know how to manage Reverse-DNS, right? If people forgot, right? I got a nice address, 129.82.138.2. That's my web server. If I want to put that in the Reverse-DNS, flip it around to 138.82.129, append in adder ARPA. There's my Reverse-DNS entry for that IP address. Done. Why not just do that for prefixes? Right? Well, people have tried to do this for prefixes, and there's an old 1990s draft by Tony Bates and by Bates and Lee and Bush and some other folks. There's been some other attempts to do variations on this. Here's my prefix. Reverse it. 1600. All I did was turn the numbers around just like I did for our regular IP address. So it seems like I don't need to give this talk. I can already do it. Only I can't. Right? So there's a couple classic problems that you run into if you try to put a prefix in the Reverse-DNS. If you haven't thought through this, think about, okay, I want to take a prefix, not an IP address. V4, V6, doesn't matter, it's the same thing. I want to take a prefix and I want to put it in the Reverse-DNS. What I just did is completely wrong. Right? My example from there, because this is a common scenario. In fact, this really is a scenario. 129.82, that belongs to my university. 129.82.0/24, that was given to some department. And I'm just going to pick on, sort of the least computer savvy department, our philosophy department. So let's say our philosophy department owns this address space. Where does this name live? Right? This is DNS. This is not CIDR. This is DNS. I go to ARPA. ARPA says go to inadder. Inadder says go to 129, says go to 82. 82 says go to the philosophy department and ask the philosophy department, what should the university's main prefix look like? It's in the wrong spot, right? This is, this is not just the university. Think of any company, any ISP who's delegating out address space. AT&T has a nice /8. Somebody, some small customer, is responsible for AT&T's /8 if we do this. It's the wrong place to put the delegation. So just reversing the octet doesn't solve the problem. Then I haven't even come to a more interesting problem of what do I do with this guy, a /17. Right? We've been able to get away with reverse DNS and IP addresses largely because they're IP addresses and they're all the way flushed out for v4 or v6. Right? But here I care about the 129 and the 82, and I only care about the first bit. Right? I only care about the first 17 bits, 8, 16, and 1. The next bit 17 should be a 1. How do I put that in reverse DNS? Well, CIDR has been around a while. Reverse DNS has been around a while. RFC 2317 comes along and says, I know how to manage the delegation structure to give the right zones to the prefix owners. And it's a bit ugly. We can, some people like it, some people hate it. But even the authors of this RFC have come back and stated now on some of the ITF mailing lists, it was not designed for prefixes. It does not work for prefixes. So we're stuck. We need a way, if you buy my premise that we should put reverse prefixes in, we should put prefixes in reverse DNS, we need a way to do it. That's what we're here to propose. There is a way to do it. So before I show you what it is, I should set some ground rules, right? What does it mean to actually successfully put it in the reverse DNS? Okay, I've got a couple I want here. First, I want autonomy. Right? And this is standard good old DNS, right? I want the owner to be able to independently create and modify data. Right? In my case, Colorado State, we have a /16. I should be able to put in anything from I16 or 17s or 18s or 24s or whatever I want below my data without going back to Aaron or Rice or whoever I want, or some parent and saying, can I add this entry to my DNS? I want it to work like regular DNS. I control Colo State EDU. I want to control my reverse DNS. I want coverage authority. So if I own my /16 or my 17 or my 18 or whatever prefix I have, I want to own all of its sub-prefixes. So, and I don't want to have to do that by independently naming each prefix. I can do that with a bunch of CNAMEs. One interesting difference between forward DNS and reverse DNS is in reverse DNS, there actually is a complete list of all the prefixes. If I own a /16, you can enumerate every possible sub-prefix. There's a lot of them. There's 65,000 of them. And you can put a CNAME or some other crazy pointer for all 65,000, but that's not really a scalable operational solution. So I'd like to be able to give away not only the prefix, but all of its sub-prefixes. Further, I want to be able to say, you know what? I own this 16, and I give you the 18. And you, in turn, give a 20 to somebody back there. And the whole system should work. That's how it works when I actually assign the addresses. I want to make that work in reverse DNS. And then, of course, I have two goals that I always want if I want to make something real. I want conformance, right? So I want to align with the conventions. I can do a great thing and say, why don't I create inadder.danandjoesapproach.something, right? Good for us, and Joe and I will have entries in that zone, but no one else will. So we want to, as much as we can, we want to conform with the other conventions that are out there, and we want to make it simple. It shouldn't take me an hour or two to figure out, now wait, I want to map this prefix into the reverse DNS. Let me pull out, let me download an entire program. I want to be able to just look at that by hand and say, how do I do it? I can do that with an IP address. I want to do that with a prefix. Okay, so to do all this, we only have a couple simple ideas. They're pretty simple, actually. So first thing you want to do is I want to get rid of unnecessary octets. Right, so here I got 129.82.00.16. The 00 is unnecessary. Those bits don't count. They're not part of the network, part of the address. Throw away the bytes, and later I'll show you the bits. Throw away the bytes that don't belong to the network part of the address. So these guys are equivalent in badly formed CIDR notation, and this is the kind of address I want to deal with. Then what I want to do next is I want to say, well, how am I going to handle these ones that are not on an octet boundary, not a multiple of 8? So here, what I want to do is I want to say, okay, I had a prefix, 129.82.160.0/17. First, the 0 doesn't matter. That last 0, none of those bytes matter as part of the network address. They're not part of the prefix. Unfortunately, some of these bytes are, right? In this case, oh, sorry, that should have been the 19. That's how I got the 3 bits there. So, yeah. So, sorry, typo on my own slide. But if I want a few bits here, right, then here are the bits I want. I want to encode those bits to handle prefixes not in an octet boundary. When the bytes are the only thing that matter, with the 129 and the 82, use them as is. When the bits are the things that matter, spell out the bits. I claim if I just do those two things and do my standard reverse, I'm done. So let me show you 2 key examples. Okay, so suppose I want to take my main prefix, my /16, 129.82.00. There's an easy step 1. Look at the prefix, remove the octets that don't matter. Anybody who does, any kind of, we all can do this. Right? We can spot, oh yeah, this is the network part, keep the network part. Step 2 is really just a complicated way for saying, am I on an octet boundary or not? Take my prefix length, 16, see what the remainder is when I divide by 8. If it's 0, I'm a multiple of 8. Done. Append in hierarchy, I put the zone in the right place. So that guy's easy. Right. Now, what happens if I'm not on an octet boundary? So here I got 129.82.64.0/16. Yeah, /18. Sorry about that. I got 2 typos there. So modifying slides too late at night on the plane. But okay, so what I want to do is first throw off the bytes, throw off the octets that don't matter. So I get rid of the 0. Now I'm going to calculate my prefix length, right? 18 mod 8. Oh, there's 2 bits left over. What am I going to do with those 2 bits? Okay, it's not going to be that hard. I'm going to do it in a couple simple steps. First, I'm going to say, all right, I need to insert an M, which is just my way of sort of remembering here I'm switching from bytes to bits. So the 64 I'm going to need to turn into bits. I'm going to insert an M right before the 64, right before the last octet. Then I'm going to say, all right, 64. I got to write 64 in binary. All right, there's a little bit of a step here, right? But come on, I mean, we're computer scientists. We can turn numbers between 0 and 255 into binary. Right? There's tools to do that. Right? You can Google that; it'll actually work. So here, if I write this guy out in binary, these are the bits. Apply the same rule as before. Don't include the bits that don't matter. Right? I wanted to keep only the first 2 bits. That's what the /18 meant. So let's keep only the first 2 bits. Here's the string I want. Reverse that string, just like I reverse the red string, just like I do in reversing an IP address, v4 or v6. Append in hierarchy, or append, or for v6, append the v6 data, and there's my name. So I claim this name has all the properties I want. With this name, as long as I can turn a number into binary, I can, by hand, take any prefix I want, map it to a unique DNS name. I get the conformance I want. I get the coverage authority I want. I can delegate out the sub-prefixes that I want to give away. And I can do all this fairly easily. So just to make that point, I'm going to show you two entries I'd throw into a zone file. So here, imagine that we give a 17 to organization A. So what I'd have to do is I'd have to go to my existing, my existing zone file, and I have to give away the 17. Right? We write the 17 in the notation. There it is. Delegate it. Just like I delegate, philosophy.colostate.edu. Note that by delegating this guy, I've delegated all of its sub-prefixes. I've delegated the 19s and the 20s and so on.
You forgot the dot at the end.
Oh yes, yeah, I should have a dot at the end. Yes. So, but I have this guy. I put this guy in here. Now, suppose this organization says, I want to give away a 19 to organization B. And by giving away the 19, I want to give away the 20 and all the stuff below it. That's easy. In that zone, I'm going to encode the 19. Notice how the 19 is a DNS descendant of the 17. Put in another delegation, away you go. So this is actually very easy to delegate out. In fact, we have been delegating this stuff out. We have a test bed where anybody can go and play. So let me then sort of push us. I'll get you the test bed in a minute. So what we have here, we claim is it would be very useful to associate data with prefixes. We also claim the right way to do that is in the reverse DNS, where we already associate data with IP addresses. We proposed a naming scheme, and we have a draft that we've submitted into ITF, and we're going to have a talk at DNS Ops, and we're seeking support from the DNS community, where we think this is the way to encode the prefixes, and we have applications that make use of the database, including a site that I'll end on here, and then I'll throw it out for questions. So try it for yourself. We have a site called roversecure64.com. Joe may have already pinned you down and showed you a demo at some point during the break. If not, we'll get to you eventually. Right. You can play and see, well, what does zone file look like? Could I actually delegate these things out? How does it work? And we, in fact, in this case, we use it for one of the applications to do route origin verification. But the point here is the naming scheme, not the use for the verification. So with that, I'm going to end by saying we should put prefixes in the reverse DNS, and this is the way we should do it, and fire at will. Right. That's so questions.